Hello and welcome to this quick look at an organic synthesis two-step leveled response 6 marker. It's specifically looking at an ester called ethyl-2-aminopropanoate. Now, you don't necessarily have to have heard of that to do the question. I've just used it in the title because you can have a look and see from the structure that it's, let's have a look, it's ethyl-2-aminopropanoate. But the question isn't asking you to name it, it's asking you to work out the starting mass of 2-chloropropanoic acid needed, the reagents conditions, equations were appropriate, take into account that it's a 64% yield. So what I'd suggest is maybe put two sections to your answer. You're calculating the starting mass bit and the reagents conditions and equations bit. So starting with the 9.36 grams of compound I, I'm going to look at compound I, my ethyl-2-aminopropanoate, and just change it into a molecular formula. So that allows me to work out 5 carbons, 11 hydrogens, 2 oxygens and 1 nitrogen, which gives me 117 grams per mole. So therefore the number of moles of that compound in 9.36 grams is 0.08 moles. Now I'm starting from 2-chloropropanoic acid, so I have to think about how I'm going to synthesize this compound. So like any ester, it comes from an alcohol and a carboxylic acid. But obviously if I'm starting with 2-chloropropanoic acid, it doesn't have the amine group there either, so I need to put that on. I need to get 2-chloropropanoic acid changed into an amine. So to do that, I can use excess ammonia. Now, you may notice that there's a COOH group on the 2-chloropropanoic acid, which also could potentially react with ammonia. Notice I haven't put aqueous or state symbols or liquid or anything like that. And there's a reason. That's because the conditions needed are excess ammonia and an ethanol solvent. There's specific reasons for both of those. So the excess ammonia, as you probably remember from your lessons on this, prevents further substitutions, either by the ammonia itself or the amine. So the amine that you make can come back and substitute here again. So we don't want that to happen. Neither really do we want the ammonia to react with the COOH group. So therefore, by putting the ammonia in ethanolic solution, in other words, dissolved in ethanol, it stops the COOH group from dissociating, because if you remember, the idea of an acid is when it produces H plus in aqueous solution, not in ethanolic solution. So therefore the COOH does not dissociate in ethanol, but it does in water. So we dissolve the ammonia in ethanol instead, and then that allows the COOH to remain intact. Okay, so the next thing to do is to think about how we're going to turn this compound into compound I. So we've dealt with putting the NH2 on there. We now have to make an ester group. So this is where the COOH does react. So we're going to do an esterification, so not forgetting the water that's made, little details at that count. We're going to use ethanol, so that part of the skeletal formula is CH3 then CH2. So as you probably know, dilute H2SO4 and reflux will allow you to achieve an esterification. So the H2SO4 might react with the amine group. So that could also be a reason that the 64% yield is there rather than a high yield. Don't be put off by that, just use the organic chemistry knowledge you have already to proceed. So the next thing to do is to focus on compound I. So you'll see that I've changed its color into pink. So we want the mole ratio of our 2-chloropropanoic acid starting material to compound I. So if you follow the two equations, you can see it's 1 to 1. So if we already worked out that the number of moles of compound I we're starting with, or that we want to actually make rather, is 0.08, the expected moles of 2-chloropropanoic acid would be 0.08. So if we go to the bottom of the screen, I'm going to finish it off down here. So 64% yield means that the actual moles of 2-chloropropanoic acid need to be scaled up. So what you do is you take the 100 and you divide it by the 64, you flip it round. And what that does is it multiplies 0.08 up to 0.125. So 0.125 moles with a 64% yield will make 0.08 moles of my compound I, which, as we've worked out already, is 9.36 grams. So converting that into a mass of 2-chloropropanoic acid that you need, you multiply the moles that you worked out you'd make, taking into account the 64% yield, by the MR of 2-chloropropanoic acid, which is 108.5 grams per mole, which gives us 13.5265 grams required. Okay, hopefully this has been a useful look at this question. It's actually quite a tricky one because you've got to think a little bit about the reagents and conditions in particular. So until next time, thanks for listening and see you soon.